Alright, dear students, now let me teach you how to find the other composite function. Okay, just now we have learned cos, compose, inverse cos, sine, compose, inverse sine, tangent, compose, inverse tangent, and vice versa. But now we have mixed the trigonometric inside an outer function. Okay, so let's do this. Inverse cos, compose sine pi over 4. So you need to be very careful. The first step is always solve for the inside function first. The tips to solve something like this is first you need to focus on the inner function. Then you can focus on the outer function. So let me show you here. The inner function will be sine pi over 4. Okay, so let's write here sine pi over 4. So let's solve. Sine pi over 4 will be equal to sec 2 over 2. So once we have solved the inner function, let us substitute here and then we can solve for the outer functions. Therefore, inverse cos of sec 2 over 2. Now we can focus to solve as usual. So as usual, to solve inverse cos, first let y as inverse cos sec 2 over 2 and then take the opposite side here. Therefore, cos y will be equal to sec 2 over. Please take care of your domain. It must be between 0 and pi for cos. Okay, so just find what is the angle so that cos of the angle becomes sec 2 over 2. Therefore, the angle is pi over 4. So pi over 4 is within the domain, so we can accept this. Therefore, we can conclude our answer. Inverse cos of sine pi over 4. This will be equal to pi over 4. Let's see for question B here. Let's solve for your inner function first. Therefore, our inner function is tangent 3 pi over 4. So let's solve this. Tangent 3 pi over 4. Let's open up our reference angle here. So 3 pi over 4 is here. Therefore, let's find our reference angle. Pi minus 3 pi over 4. So this is pi over 4. So this is quadrant 2, the house of sine. So you need to put negative here to solve for reference angle. So negative tangent, pi over 4. Therefore, the inner function will be negative 1. So now let's rewrite into the outer function inverse sine of negative 1. So to solve this, we need to let y as inverse sine of negative 1 and then find the opposite. Sine y is equal to negative 1. Make sure your domain is within negative pi over 2 until pi over 2. Now let's find the reference angle first. So y for inverse sine 1, so you'll get the answer of pi over 2. So let's draw our quadrant here. If sine is negative, confirm you are in the fourth quadrant. Okay, so reference angle here is pi over 2. So how to read your angle? So you know that you're allowed to be in quadrant 1 and quadrant 4 only. So since you're negative, you are here in quadrant 4. The reference angle is pi over 2. So the way to read this is you need to read clockwise version. So the angle is negative pi over. So now let's conclude our answer. Inverse sine of tangent 3 pi over 4. Your final answer will be negative pi over 2. Now let's see this question here. Let's solve for the inner function first. So for the inner function, you have inverse sine of 12 over 13. Okay, so when you get inverse, make sure you let y. So let y as inverse sine 12 over 13. So now let's go to the opposite side. Sine y is 12 over 13. So we don't have exact number to solve this, meaning that we need to implement the triangle method. Okay, so let's see here. For sine y, you're allowed to be within negative pi over 2 and pi over 2. So you are either quadrant 1 or quadrant 4. So since sine is positive, confirm you are here in quadrant 1. So let's draw a triangle here. This is your y. So now let's read the sign. Opposite over hypotenuse. Okay, 12 over 13. So let's use Pythagorean theorem to get the other side. This is 5. So now let's focus on your outer function. Secant of inverse sine 12 over 13. We already put it as y just now. So secant y. So just read your secant y from the triangle here. So secant is 1 over cos y. So let's read your cos. Cos y will be 5 over 13. Okay, so let's solve that. So the final answer will be 13 over 5.